So today I am building John Conway's Game of Life in Minecraft. I've built out all of the boilerplate background code. I've got my commands listed here for saving and loading boards. I have my events here, and that's for creating the boards. And then I have a point helper class, which saves a point and can deserialize from a string. A selection, which is basically just a collection of points as well as a y coordinate and a world. And then my main class, which calls it. So the Game of Life class, or the goal class here, is going to be where all of the magic is actually happening, right? So this is where we're going to apply the 4 rules of Conway's Game of Life to iterate over the entire board every however often. So that interval is going to be configurable, possibly through commands, not sure yet. We'll figure all that out as we go. So for now, we just need to fill out run, stop, and iterate, where iterate is going to be our first, and then we'll just have that going on a timer. So when we iterate, we have to loop through, just like we did here in the reset function. We have to loop through every block and check its neighbors, and then determine what happens to that block based on those neighbors. Put all of those into a list, and then apply that list to the whole board. At least that's my goal for it. So we'll see how it goes. So what we're going to do to start, I suppose, is create a list of lists of blocks. We'll call this blocks. Like so. There we go. And then we'll just copy and paste these 2 loops, because that's probably going to be the easiest way for us to build that out. And here we go. This gets our block at that location. And instead of doing if it is white continue, because we're not actually just resetting everything to white here, we're doing a little bit more logic related. So I've created a function down here, is live, and we'll just do if is any live cell, any live cell, any live cell, and any dead cell. So we're going to apply rule 1. We'll do this. Private void apply rule 1. We'll do private void apply rule 2. And I can't type today. We'll copy, paste 2 more times here for 3 and 4. And what we're going to do is we're going to take in block B, that way we can apply it to that block, and we don't actually have to do anything in the loop. We can just say apply rule 1 to B. And we'll do if is live. There we go. We can copy this and do 2 and 3, because rules 1, 2, and 3, as you can see here, are all regarding a live cell. And then the last one is a dead cell. So else apply rule 4. Pass in B there. Okay, so now we can just do 1 rule at a time, and it's a little more modular. So any live cell with fewer than 2 live neighbors dies. So that would be underpopulation. So we're going to say, we're going to need a helper function here to get live surrounding, or get neighbors. And neighbors is we're only going to care about living neighbors, because dead neighbors aren't neighbors, right? They're just corpses. So private int get neighbors of block B. Alright, we're going to just do this quick and dirty, something really simple so I don't have to think. We're going to say int I equals 0. We're going to say if b.get, because neighbors, does neighbors count corners? I don't know if neighbors counts corners or not. Okay, here we go. If any live cell with more than 3 live neighbors dies, more than 3, but 2 or 3 live neighbors lives unchanged to the next generation. Well, one thing we know, right, is that if we have, this is a really easy one here. Let's find black concrete. If we have this pattern, right, this in one generation will iterate to this. So it's like a T flip-flop, right, where it flips between these two states indefinitely. And that's because this one has a neighbor. So this one, let's just grab, this one's going to be one that doesn't die, right? That one never dies. It stays there all the time, while these two and these two die and are reborn over and over again. So this one has 2 neighbors, so it lives. This one has 1 neighbor, so it dies. This one has 1 neighbor, so it dies, right? If we have this, all of them live. So this one right here has 3 neighbors, so it lives. This one has 3 neighbors. This one has 3 neighbors. So corners count. The way to test it would be to do that. If this one then dies, overpopulation. So we'll just test that out here. Don't mind all of my tabs, I've got plenty. If we just clear the live viewer, zoom in here, and do that, and then iterate forward once. That one died, those 2 were born. So it turns into a Y. That becomes this, right? Right? So what's happening here is this one survived. These 2 survived. Those 2 were born. These 2 died. So this one had 3 neighbors, but 4 because of the corner, right? So it died. This one also had 4 neighbors because of the corner, and it died. Otherwise, they'd have lived if it was just the sides. So yeah, corners do count. Good. Perfect. So get relative block face dot. We're going to go north. We'll go if is live, right? Because that means it's a neighbor. Then I plus plus. And now we're just going to go through all 8 of them. North, north, east, east, southeast, south, southwest, west, and northwest. There we go. Now we return I, and that gets us the number of neighbors. And we can clean that up later on or do something else maybe, but for now that's going to do just fine. So for applying rule 1, we need to know any live cell with fewer than 2 neighbors dies. So if, how do we apply the rule actually though? Because we're not going to change the block dynamically, otherwise it's going to throw everything off. We have to change it once per iteration, right? So when we are running our iterate, we need to put it into blocks. So we need to apply rule B blocks. That way we can directly reference the list, right? So we'll just do like that. No, we don't need to do that there. Wrong one. Apply rule. U, like so. So now all of them have access to that list, and we can say if get neighbors b is less than 2, we only apply one rule. So we'll say if, we'll have to return a boolean off this whether or not the rule got applied. So if this continue, and then else if second rule, and then again for the third rule. I guess we don't need to do it here because it's if this, else this, right? So this is like last resort rule. This rule's gonna apply. So we can just take that back out of the loop. Okay. And then we'll have them all return booleans. And they're all gonna throw an error because they're not currently returning anything. So just to clean that up, we'll put a return false at the end of each. We'll put our code on top of that. So if get neighbors is less than 2, then blocks. I don't like this. I don't like doing block and block. I think we need to run these as a can apply rule, can apply rule, can apply rule, and if can apply rule, do something to it here. That way we already have our I and our j. We know where we're at in our list, and we know what we can do with it, right? As a matter of fact, in that case, we could use a multidimensional array instead of lists. It'd be a little lighter weight and probably a little tidier. Yeah, let's do that instead. I think that's better. So we're gonna have block array, and we'll call it blocks, right? And we're gonna have to do equals new block array of size B is going to be the larger X and Z. I've already ensured that elsewhere. So we'll do B minus X, right? Hopefully I don't get my coordinate system backwards here. And we'll do the Z I hope I'm doing this right. Alright. Minus that. There we go. If it ends up being wonky, I can debug it then, but I want to save time and just pretend that I got it right the first time. So block. There we go. Multidimensional block array of size, width, and height, right? Probably going to get an index out of bounds exception, or an index out of bounds exception, because size, if we're at 10 and 5, right? Our size is 5, 6, 7, 8, 9, and 10. So that's 6 blocks. But if you subtract 10 minus 5, you get 5 blocks. And so our size is actually, the size of our array is going to be slightly too small. And that should fix it. Minus that plus 1. I should fix it. I'm just going to allocate the space for the array. and then we can just put it into each slot as we go. And then our x slot is going to be I minus a get x. Our z is going to be j minus a get z. Okay, this should work. Should work. Here we go. Apply rule 1, then do a thing to the blocks, move into array, and continue, which means we actually don't need a multidimensional array of blocks here. We need a multidimensional array of material. Because that's all we really need to store is the material that we're going to change the block into, and then we'll iterate through afterwards. Because this is applying all the rules. Ooh. And then we'll have afterwards a loop to go through the entire thing and set everything. And we do have to do it in 2 separate loops. We can't do it dynamically row by row because it'll screw everything up. Okay, so we don't need to pass in blocks at all. We just need to get the surroundings and then return whether or not that rule should apply. Continue, we'll then skip checking the next one. But we have else if anyways. We don't need to do continue for these 3. Maybe we'll just not do else loops. I like that better. I don't want to have all these else's here. I think this is better. If not live, apply this. And it's the only rule that can be applied to a not live tile, right? And that's going to be all of them at first. All of them are going to have rule 4 applied to them, except for the couple that you select. And then after that, it starts exploding out, hopefully. Okay, so if get neighbors is less than 2, return true. So return, we can just do this instead. This will be much tidier. This is the way to do it. And all of this goes away. Return get neighbors is less than 2. That's apply rule 1. Any live cell with more than 3 live neighbors dies. So both of those are going to die. Rule 1 kills a cell. Rule 2 kills a cell. Rule 3 sustains a cell. And rule 4 births a cell. Okay, so get neighbors is there. If it is more than 3, return get neighbors is greater than 3. Return get neighbors equals 2 or get neighbor. Well, we can do and it's greater than 2. Equals is easier here. Greater than 1, less than 4 type thing, but equals 2 or three. Okay. Any cell with exactly 3 is born. Okay. So here we need to kill a cell. And here we will kill a cell. We need to remove these blocks parameters. Those aren't used. Kill cell. Sustain cell. Birth cell. Okay. So apply rule 1, we say blocks I and j, where I iterates over x, j iterates over z. So that's correct, because x and z is first and second slot here, equals material dot, we're killing it, so white concrete, right? Same here. This one sustains the cell. So black concrete. This one births the cell. Also black concrete. There we go. So now we just need to loop through and set all of the materials to all of the blocks. So we're going to do this exact same loop again, right here. And here we need to, oh boy. B set type blocks ij, right? No, not I. We do I minus this, minus that, and j minus that. Because otherwise, we would have to start the board on 0, 0. And I don't have to do that because that's garbage, right? Garbage programming leads to garbage software. That's not what I like to make. It's what I'm good at making. It's not what I like to make. J X. Okay. Okay, let me check my commands here. Run. I have run as a command. So it's going to just call this function. So this function, what we can do is we can say right, okay, and call it iterate, and then we're going to have right here private runnable, and we'll say runnable equals new bucket runnable, and then runnable dot run task timer. We're going to have to pass in main and save it here. Okay, and then we'll just pass in main, and then for our, what was it, delay and interval, yeah, delay and period, so 0. Now we'll give it half second. Seems like plenty of time, right? We can iterate over everything in a half second, right? Maybe, hopefully, we'll see. Okay, and then on stop we need to go if runnable not equal null, then runnable dot cancel. Go. And that should cancel the runnable without having any issues anywhere. And now we need to pass in main. We should be good to go. So we can just export this to my test server. I know I'm missing something. I gotta be missing something. Can't be that simple, can it? Reload. reset test. Test is the name of the board. So reset it. This is our test. Perfect. Error. That is what you're after, you know. Plugin cannot be null? Why would it be null? Oh, you know what? I think I'm a moron. I am a moron. This dot main equals main. There we go. Export. Reload. Oh, that is not the intended function. Okay. What are the corner pieces? Well, that's kind of fascinating. I didn't mean to just invert. It is kind of doing its job. I mean, those ones would be living and dying in alternations, but middle one should be staying alive, and all of these should not be changing. So, well, the command works. That's good. No, I can just reset. There we go. Easy peasy. So, let's look over this then. Maybe we should make a smaller test board. Let's do that real quick. And we'll just put it right inside of it here. So we'll go create, select. Now we can use goal mini, and it's saved. Oh, intriguing. Why? I wondered if this would happen actually. So it thinks that only this strip is the board. Oh, the function that I made probably just sucks. That's going to be in normalize, selection.normalize. I made a normalize function, and it was so that I could have the first point always be the smallest number on x and z. The second point always be the largest number on x and z. But that doesn't necessarily always work. So what I need to do instead is create a new point. I don't remember what I did before. I did something on the factions plugin that I made one time for this. And was able to iterate over chunks, and I needed to do it smallest to largest because I was doing like 3D scanning of a structure or something. So if we have a grid, sorry, I'm drawing on paper here, but fast thinking. If we have point, 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 where these are 1, 10, x and y, this is 1, 1, this one is 10 and 1, and this one is 10 and 10. If we have these two selected, bottom left and top right, it's going to iterate additively on the x and then on the y, and therefore iterate across properly. But if we instead have these two corners selected, more importantly, what if we select them? Does the order of the selection matter? Not if we normalize it. It's just 2 points at that point. So if we have those two selected instead, and we iterate plus on the x, we can't then iterate plus on the y because we've got the wrong one selected. But if we get the smallest of x on both of them, and the smallest of y on both of them, that should put it back in that corner, right? Smallest x and smallest y is still going to be, so x, if we get min of x and min of y between a and b's points, well, that might do it. Perfect. No, that actually makes sense. That makes sense because I didn't properly put in a selection here. So reset. Okay, so that's the outside edge. And then our other outside is going to be like over here somewhere. Oh, okay, so there we go. Okay. Perfect. Now, if we go goal, run, mini. Interesting. So, why is it just saying Boolean if was not now? Why are the corners? Why do the corners go dark? Is live is the only thing that it counts, not is dead. So it's checking only live neighbors. If white concrete, how do we actually check that? Is live. If it's black concrete, it's alive. Anything else, and it's dead. So it's saying there are no live neighbors here. Then why is it alive? I'm so confused. I had to have screwed something up. Rule 1. If neighbors is less than 2, cell should die. And they did not die. They did not die. That's rule 1. Rule 1 should be applied right off the bat, no matter what. If get neighbors of block B is less than 2, return true. If apply rule 1, then we kill the cell. Right? That's going to be obnoxious. Let's do this. Actually, if we do this, rule 1 should never print out. Now it's applying. Now it's applying. See? Why did it kill the 4? They should not have died. But rule 1 is applying to those. They are dying, but then all the rest of them are coming to life. So coming to life might actually be the issue here, right? Rule 4 might be the issue. How many of them are dying? Why did I do that? Here we go. Should still be applied by the Boolean. So this may work. Next import. Reload. I mean, he's running, but ain't nothing happening. Nothing happening. So only rule 4. If neighbors is 3. This one has 4 neighbors. This one has 4 neighbors. This one has 3 neighbors. This one should be living right now. 1, 2, 3. Right? Is live. Else, if not live, we can apply rule 4 to that block that is not alive. Or is live. It's live if it's black. If it's white, it's not. So, if apply rule 4 does work, if get neighbors returns 3. Just checking is live in the north. Get relative returns a block to the north. I've used that function so many times. I++. If is live, b dot get relative northeast. South, southwest, west, northwest. So that's all directions. We've got iterations on each. If is live, I want to see how many neighbors it's detecting. We could say, well, we should reset it first, right? So stop it, goal, reset, mini, reload. We're going to put one right here. It has no neighbors. They each have 1. They each have 2. They each have 3. Some 4, some 3, some 2. Okay, so that's working fine. That's perfect. Perfect. Good to know. So get neighbors is good. We're good. We know how many neighbors we've got. When we have 1 neighbor, if is live, yes. If apply rule 1, less than 2, get neighbors is less than 2, we're returning true because of that. So yes, then kill cell. Blocks. Where I starts out equaling this. So if this is the very first block we check, I equals selection.getA.getX, where A is the first point, X equals the X coordinate. Then we get blocks 0, 0, which is I minus, where I equals this, we're doing I minus this, which equals 0, so it's 0 and 0. So the first cell we're iterating over, and the first cell we're iterating over. So a perfect match, block set type of array blocks, I minus selection A got get X, and J of the same. I'm missing something. And then we continue, right? One rule won't apply when another will also apply, so we don't have to have continue here. What is running? Nothing is happening. Nothing should be happening. That's a square. We're going to select there, 3 by 3. No larger. Go create. Oh. Let's go create you and you. That should overwrite. Yep. Now we will output for every rule being applied. row 1, 2, row 3, row 4. We'll see what's actually going on here. Clear chat. Place 1. Rule 1 is being applied. Oh. Interesting. So this one is dying. That one is not. Wait, row 4? Row 4. This one should be coming to life. So, row 4 is being printed, but nothing's happening. Wait. Row 1 is being printed out. That is not. What? Material is null? Should set Okay. That's quite possible, but that was the fix. I was not handling else if none of the rules apply because it has no neighbors and it's dead, right? So if it has no neighbors and it's dead, you still need to set the material to something. And that material would be white concrete, because you can't set it to null. So, should be able to reload. We'll set that. We'll go like this. We'll say, run mini. And it works. Okay. So, we'll stop, and we'll reset. We'll clear all the spam, which is a lot. Okay. I knew it couldn't be that simple. I was going to screw something up. Guarantee it. Reload. We'll reset test. The ultimate test. Is it that? It's that. Do two of them. I guess we'll see. We found it. Look at that. Nice. Okay, so now we need to increase the interval because I think we can. So we're going to do this instead of on a timer of 10. We're going to do it on a timer of let's do 3 and see how we do there. Hopefully it doesn't lag us the heck out. Cool. Reset. Test. Cool. Stop. Test. Now we can do reload. We're going to have some fun with it. Right, and then we're also going to just right over here give us a little traveler, and let's get somewhere comfy. Just see what happens. Beautiful. Beautiful. Look at it go.